This is Clinical Conversations. This week, we're going to talk about why mumps, annoyingly, keeps showing up like a skunk at the garden party and what clinicians can do about it. Our guest is Dr. Joseph Lewnard, co-author of a paper in Science Translational Medicine last month. Dr. Lewnard is a research associate at the Harvard T.H. Chan School of Public Health. Welcome, Dr. Lewnard.
Thank you for having me. It's a pleasure.
I want to reassure listeners that although you based your analysis on mathematical modeling, we're not going to speak in equations or even about equations. We'll keep this as practical as possible. But here's the first question then. What were the suspected causes of the reemergence of mumps in the United States?
Well, since about 2006, there's been a noted increase in mumps cases, or at least in detection of mumps cases, largely in outbreaks affecting vaccinated populations, which is quite different from the picture we see with, for instance, measles, which has largely been focused in communities with low vaccine coverage. So there's been suspicion that something might be off with vaccine protection in the affected groups. One thing that's under consideration, or has long been under consideration, is that genotypes of mumps currently circulating in the United States in these outbreaks are evading vaccine-driven immune pressure. For instance, from the genotype A used in the original mumps vaccine that we still use today. The other possibility that's attracted some speculation has been that protection might wane over time, such that the young adult college-age populations that have experienced the majority of recent outbreaks might be underprotected by prior vaccination.
Okay, so the most recent outbreaks have been among college-age people. And as we'll maybe mention later, there haven't been any among Army recruits, but it's been mostly among people who are together in living together. But the Army recruits, I'll let you explain something. Say why the Army recruits aren't getting mumps.
This has been a very interesting point. I'm glad it's something that you brought up, and it's certainly something that we, at least anecdotally, brought up in our paper, that the Army has long, since over a decade, had a policy of giving everybody an MMR dose at the time that they enter into service. So into basic training, they get a number of vaccines and medications, but one of them is MMR. And this is done throughout the Army, with the exception of the Air Force, for everybody, rather than based on serological titers or vaccine history. It's notable, I think, to say this because the Army is obviously a similar congregate population of people of roughly the same ages as those going into colleges and other close contact settings where we've seen outbreaks. And yet, since they've been doing this revaccination policy, if you will, they have not really been as much at risk for mumps outbreaks as colleges and universities, for instance, have been.
Yeah, so that kind of gives us all a hint as to something was going on that was somehow tied to vaccination. And the fact that, well, we'll get to that point later. I want to know what got you interested in this problem.
I would say that the Harvard outbreak has certainly been at the forefront of our attention since it's going on, not necessarily here at Longwood, but right across the river in Cambridge. And although I have not had mumps, I've certainly heard some stories about it, or at least it's been receiving attention. I think also the sort of open question of what could be behind outbreaks in vaccinated populations it's not something that's only been thought of by me. There's been series of commentaries and editorials in journals for about 10 years now with people taking positions either that we need a new vaccine policy to lengthen protection into young adult years because protection might be waning, or B, and perhaps more concerningly, we might actually need a new vaccine against mumps, which targets the genotypes currently circulating and maybe could also provide a broad cross-genotype protection to avoid this happening again. So this is actually something that's not just of academic concern as to why mumps is back, but has real implications for vaccine policies and vaccine development moving forward. So it was very much something that I think is of interest to the pediatric infectious disease community broadly.
Okay. And so how did you attack solving the problem, solving the question, okay, have we got a bad vaccine here, or are the genotypes changing, or is vaccine protection waning, as you say?
I think that what's convenient about the hypotheses as formulated is that they give us some testable predictions. So one is that we should be able to see over time, in the case of vaccine waning, that the estimated protection conferred by vaccine in vaccinated populations should be going down with age or with time since a last dose was received. A second hypothesis that can be tested from the consideration of strains emerging to evade the immune response is that over time, as the strain population of mumps virus in the United States and other settings has shifted, that there should be a lower degree of protection against circulating strains with these decades since vaccines were introduced. So we could actually test this with the number of studies, the mumps vaccine performance that have been done over the decades. And one thing that's interesting to note about these studies is that there's been a huge amount of variation in the estimated effect of mumps vaccines, ranging from as low as the 40% range to well over 90% in earlier clinical trials. Are the first New England Journal paper estimating the effect of mumps vaccine. And what we found when we did this was that much like we would predict with the case of vaccine waning, the protective effect did seem to go down with longer time since receiving the last vaccine dose. From this, we could estimate that protection is essentially lost by about 50% of people within 19 years of receiving their last dose of mumps-containing vaccine. And second, that there had been, after controlling for this association with age, really no association of time in terms of the decades that have passed since vaccines were introduced with the degree of protection conferred. So much of the variation, actually a very large majority of the variation in estimates of mumps vaccine performance we found could be actually predicted by the age or the time since individuals had received their last dose. So very much in line with the idea that immune protection is waning in the population after receiving vaccine.
Let me stop you for a second. And I just want to give the listeners a sense of how you pulled together the data against which you tested your hypotheses. So I think you said earlier on that you looked at studies that had taken place over 5 decades. I think there were 6 studies done over a 50-year span or something.
Yeah. There's a large number of studies have been done. We tried to limit it down to the 6 studies which we had all the information we needed, which was an actual estimate of the relative risk of clinical mumps associated with vaccination given time since receipt of the last dose. So all of the studies which give a design and reporting that were sufficient for us to get at that question we included, which came out to only 6, but were well designed and also included in many of the studies estimates from individuals who had received mumps vaccine different time lags up to the time of an outbreak that they were conducted in.
Okay. So what you did is you applied some, I'll use the magic word, equations to that data, and you tested your hypotheses against what the data were telling you. And what did you find when you did that then?
So when we did that, what we were able to show was that protection indeed was closely associated with the time since individuals had received their last dose, such that we would estimate about 50% of individuals that lose protection within 19 years of receiving a mumps vaccine. And second, that there wasn't a whole lot of variation in vaccine performance associated with the decades passing since the 1960s when mumps vaccines were introduced. So in other words, not a whole lot of evidence that there's been a broad change in vaccine performance with the replacement of genotype A mumps by other strains in circulation. So this was really in favor of the hypothesis of waning immunity as a driver of variation in vaccine performance.
And one of the things that you say in your paper is that if there were new genotypes of the mumps virus circulating, you would expect that they would be affecting younger children as well, and you don't see those outbreaks in young kids who've been vaccinated.
That's absolutely true. So one thing that we were able to do with our transmission model that we developed of mumps in the United States was to go forward and test whether the occurrence of cases in terms of the frequency of cases and also the age groups that they affected was more consistent with what we'd expect from vaccine waning as we estimated, or alternatively with the emergence of new genotypes that were able to evade the response to Gerald vaccine. And what we were able to show there, exactly as you say, is that we'd expect mumps cases to be much more concentrated among younger children if vaccine waning were not playing a role in protection in older age groups. So we'd expect that new strains should have a transmission pattern a lot more like mumps did historically when it was focused in 5 to 9-year-old.
And so you say that the time since last vaccination accounted for about 2/3 of the unexplained vaccine failure to protect. Now we've been talking about epidemiological things. Let's get down to clinical brass tacks. What you offer some advice about? Okay, so if the vaccine works, but it wanes in its protection over time, you say, gee, maybe there is another way to boost that protection so that older people, younger people, and people my age, well into their 50s, 60s, 70s, can be protected. So, what do you suggest that is a good public health measure?
Well, I think that a good public health measure moving forward is to assess the performance of additional doses. So, for instance, a third dose administered in the pre-college age groups to see if this could extend protection into the groups that have been at risk in recent outbreaks. It's worth noting that very recently a new recommendation was issued in the United States for vaccine doses to be made available to people regardless of whether they've previously been immunized, but in the context of outbreaks. And this was on the basis of evidence from a study in University of Iowa during an outbreak this year when additional doses were shown to be effective in an outbreak setting. However, I think that moving forward, there's some interest in not only showing that you can intervene in the context of an outbreak, but also ultimately in preventing outbreaks. So I think that trials are warranted to determine the strength and duration, importantly, of protection from an additional dose or a later dose in childhood to extend protection to these young adult age groups that have recently been at risk. And this again echoes our experience with just anecdotally how the military has avoided this problem in large part, despite being a somewhat similar setting to college campuses where outbreaks have been occurring lately.
So you would hope that there'll be more research done on this, but you certainly agree with the advice that during an outbreak, it's the best thing to do is to have another dose of the vaccine, and it's more likely to happen among. Well, you don't know where it's more likely to happen, but if you're in a group of people among whom there's a mumps outbreak, get vaccinated. Would that be your advice?
Yeah, that's definitely the indication right now, and that's definitely the recommendation right now. And it's important for people to be aware of this, even if they have received a vaccine previously, that they're still recommended to go get a dose in the context of an outbreak when they might be exposed.
All right. Thank you for talking with us today, Dr. Lewnard.
Thank you for having me. It's been a pleasure.
That was our 220th edition. All earlier conversations may be found at podcasts.jwatch.org. We come to you from NEJM Journal Watch. Kristen Kelly is the executive producer here for the NEJM Group. I'm Joe Elia. Thank you for listening.